Right now, this very second, a machine is calling to you from the edge of the solar system. You cannot hear it, but it is there, a radio signal, barely stronger than a refrigerator light bulb, traveling for 22.5 hours through empty space just to reach Earth. The signal carries a simple message: I am still here. I am still alive. And here is what you need to understand. That signal should have stopped decades ago. Pause here. September 5th, 1977. Its mission: visit Jupiter and Saturn, take photographs, then drift into the void forever. No one expects it to last more than 5 years. The power source? 3 plutonium generators. They produce electricity by converting radioactive decay into heat. But plutonium decays, the power drops. The engineers know this. They build the spacecraft knowing it has an expiration date. 5 years. Maybe 10 if they are lucky. That was 48 years ago. And the spacecraft is still transmitting. Let that land. You want to understand how far away Voyager is right now? Try this. When you send a text message to someone across the planet, it arrives in milliseconds. When you stream a video from a server thousands of kilometers away, it buffers in seconds. When Voyager sends a signal to Earth, it takes 22.5 hours to arrive. Not minutes, not seconds, hours. Think about that. You could send a command to Voyager right now, this moment, and the spacecraft would not receive it until tomorrow. Same time. Tomorrow. If you wanted a response, add another 22.5 hours. That is 45 hours between question and answer. 2 full days. Now imagine you are the engineer responsible for keeping Voyager alive. It is 3 in the morning. You are alone in the control room at the Deep Space Network facility in Canberra, Australia. The only sound is the hum of electronics and the faint static of the universe. On your screen, a single line of data. Signal strength, -164 dBm. You know what that number means. It means the signal reaching Earth from Voyager has a power of less than a billionth of a watt. To put that in perspective, all the energy collected from Voyager's signal since 1977, every photograph, every measurement, every bit of data transmitted across billions of kilometers adds up to less energy than it takes to melt a single snowflake. You are listening to a whisper, fainter than you can imagine. And you know something else. Pause here. In a few years, maybe 5, maybe 10, that signal will stop. Not because the spacecraft will crash, not because it will break down, but because the power will run out. The plutonium is decaying. The generators are producing less electricity every year. One by one, the instruments are shutting down to conserve power. The cameras shut down in 1990. The Planetary Radio Astronomy Experiment, 2007. The Plasma Spectrometer, 2008. The Ultraviolet Spectrometer, 2016. Each shutdown buys a few more watts, a few more months, a few more years. But the countdown is absolute. One day, maybe tomorrow, maybe in 10 years, you will sit at this console, and the signal will not be there. Just silence. Now watch what happens when you realize this. You start paying attention differently. Every transmission becomes precious. Engineers archive every bit of data, knowing the data set is finite, irreplaceable. This is not like monitoring a satellite in Earth orbit, where you can send a repair crew if something breaks. This is not like the Hubble Space Telescope, which was serviced 5 times by astronauts. Voyager is alone. 24 billion kilometers from Earth, unreachable, irreparable. When it stops forever. And yet, here is where it gets strange. The spacecraft keeps surviving. 2010, a thruster begins misfiring. The spacecraft detects the problem, switches to backup systems, and continues functioning. The engineers do not know about it until a day later. By the time they receive the alert, Voyager has already fixed itself. 2017, the main thrusters, unused since 1980, sitting dormant for 37 years, begin to degrade. Engineers send a command to test the backup thrusters. 22.5 hours later, the command arrives. The thrusters fire perfectly. 2020, the attitude control system starts using outdated star maps from the 1970s. Engineers rewrite the software written in a programming language almost nobody uses anymore, and upload the patch. It works. 2023, a memory glitch corrupts data transmissions. Engineers spend months diagnosing the problem remotely, testing solutions, before sending a fix. It works. You see what is happening. The spacecraft is teaching us something. Autonomy is not optional at these distances. It is required. Pause here. Now let me show you something that will change how you think about distance. You know Voyager is far away, 24 billion kilometers. You have heard that number, but do you understand what it means? Try this.
Light, the fastest thing in the universe, takes 8 minutes to travel from the Sun to Earth. That distance is called 1 astronomical unit, about 150 million kilometers. Voyager is 163 astronomical units from Earth. If you scaled the solar system down so that the Sun and Earth were 1 meter apart, Voyager would be 163 meters away. Still with me? Now consider this. The nearest star, Proxima Centauri, is 4.2 light-years away. That is 268,000 astronomical units. On our scale, where Earth is 1 meter from the Sun, Proxima Centauri would be 268 kilometers away. Voyager, after 48 years of traveling at 17 kilometers per second, has covered 163 meters. It would take Voyager 73,000 more years to reach Proxima Centauri. Let that sink in. And yet, despite the distance, despite the impossible odds, despite the fact that every reasonable projection said the spacecraft should have died decades ago, the signal is still there, right now, transmitting. You want to know what it is saying? Not much anymore. In the beginning, Voyager sent photographs: Jupiter's great red spot, Saturn's rings, the volcanoes of Io, the icy plains of Europa, thousands of images, each one broken into digital packets and beamed across hundreds of millions of kilometers. Those days are over. The camera is off. There is nothing left to photograph. Now the signal carries only telemetry, numbers, data streams, cosmic ray counts, particle density, magnetic field strength, temperature, power levels, system diagnostics. To you it would be meaningless, a string of ones and zeros, but to scientists, each number reveals something about a region of space no human has ever studied. The heliopause, the boundary where the Sun's influence ends and the galaxy begins. Voyager crossed that boundary in 2012. It became the first human-made object to enter interstellar space, and it is still sending data, still measuring, still observing. Pause here. Think about what that means. A machine built in the 1970s, before personal computers, before the internet, before mobile phones, is functioning perfectly in a place no human will reach for centuries. The technology on board Voyager is laughably primitive by modern standards. The onboard computer has 8 kilobytes of memory. 8. Your smartphone has millions of times more memory than Voyager. The data transmission rate is 160 bits per second, slower than a 1990s dial-up modem. The camera used magnetic tape, actual physical tape, like a cassette. And yet this ancient primitive machine is still working, still transmitting, still exploring. How? Here is the secret. The engineers who built Voyager knew they could not predict every problem, so they built redundancy into everything. 2 computers. If one fails, switch to the other. 3 gyroscopes. If one drifts, the others compensate. Multiple thrusters. If the main system fails, activate backups. Shielding around critical components. Protection from cosmic rays that can flip bits in memory. Self-diagnostic routines that check systems constantly, looking for anomalies. They built a machine that could survive alone, and it has. Now watch what happens next. But here is the thing about survival. It is temporary. The power is dropping. The generators are cooling. The spacecraft is running out of time. Engineers estimate Voyager will fall below minimum operating power sometime between 2025 and 2030. When that happens, the transmitter will shut down. The spacecraft will continue traveling. It will drift through the galaxy for billions of years, long after Earth is gone, long after the Sun has died, but it will be silent, and we will never hear from it again. Pause here, let that settle. You might wonder why this matters. It is just a machine, right? A chunk of metal and electronics drifting through space. Why should you care when the signal stops? Here is why. Voyager is not just a machine, it is proof. Proof that humanity can build things that outlast us, that function beyond our control, that venture into places we cannot follow. Proof that distance is not an absolute barrier, that even at 24 billion kilometers connection is possible. Proof that we can reach into the unknown and bring back understanding. Every day that signal reaches Earth, it tells us something profound. We are not confined to this planet. Our reach extends beyond the cradle. Pause here, but there is something else Voyager is carrying, something you probably do not know about. Attached to the side of the spacecraft right now, as it drifts through interstellar space, is a golden record, not a metaphor, an actual record. 12 inches in diameter, gold-plated copper. On its surface, instructions for how to play it, encoded in universal scientific symbols. Inside, sounds and images from Earth, greetings in 55 languages. Hello from the children of planet Earth. Music, Bach, Beethoven, Chuck Berry, Peruvian panpipes, a Navajo night chant, natural sounds, thunder, wind, waves, birdsong, a baby crying, human sounds, a heartbeat, footsteps, laughter, a kiss, and 116 photographs, a diagram of DNA, a woman nursing a child, the Great Wall of China, a supermarket, a violin, a sunset. Now here is the question, why? Why include a record that will almost certainly never be found? The odds of another civilization encountering Voyager in the vastness of space are absurdly small. The spacecraft will drift for 40,000 years before it passes near another star. Gliese 44.
Even then it will be light years away, so why bother? Think about that for a second, because the record is not really for aliens, it is for us. It says something about who we are, about what we value, about our capacity for hope. Launching that record into space is an act of defiance, against isolation, against the indifference of the cosmos, against the certainty of our own extinction. It says we were here, we existed, this is what we created, this is who we were. Even if no one ever finds it, the act of creating it matters. Let that land. You are living in the only moment in history when Voyager's signal exists. Before 1977, it did not exist. In a few years it will not exist. But right now, this second, it does. A faint radio wave, carrying the voice of a machine built by humans, traveling through the void at the speed of light, the loneliest signal in the universe, and we are still listening. Pause here. Now imagine the moment when it stops. You are the engineer on duty. It is 3 in the morning. You are watching the signal strength indicator. For 48 years, that line has been there, weak, fragile, but present, and then one day, it is not. The line goes flat, the signal disappears into the background noise of the cosmos. You check the systems, you verify the dish alignment, you run diagnostics, nothing is wrong on your end, the signal is just gone. You sit there for a moment, alone in the control room, staring at the screen, and you realize, Voyager just transmitted its last bit of data. Somewhere out there 24 billion kilometers away the spacecraft has fallen silent, it will never call home again. What do you feel in that moment? Sadness, maybe, the end of an era, the closing of a chapter in human history, but also something else, pride. Because that machine built by humans with slide rules and pencil and paper functioned perfectly for nearly 50 years in the most hostile environment imaginable. It survived radiation, micrometeorite impacts, extreme temperature swings, the decay of its own power source. It explored worlds no human had ever seen. It sent back knowledge that changed our understanding of the solar system, and it carried our message into the cosmos. A message that says, we are small, we are brief, but we are not insignificant. Pause here. Voyager is still out there right now. Still traveling, still drifting deeper into interstellar space. In 300,000 years, it will be farther from Earth than any star you can see in the night sky. In a billion years, it will still be intact, carrying that golden record through the galaxy, long after you are gone. Long after everyone you know is gone. Long after human civilization has either spread to the stars or collapsed into dust, the spacecraft will endure. A silent monument, a time capsule, a message in a bottle, cast into an ocean larger than comprehension. And for just a few more years we can still hear its voice, faint, fragile, but real, the loneliest signal in the universe, calling home. Are you listening?